Hello guys, my name is Craig and welcome back to Peri Solutions. If you're new to my channel, please make sure you hit the subscribe button and turn on the notification bell. In today's video, we're going to talk about how we calculate the areas of shapes, namely the rectangle, the trapezium, the kite, the triangle, and as well the parallelogram. So I'm just going to start off by giving you a quick rerun of the formulae that we use when we need to calculate the areas of these shapes. So firstly, we've got the rectangle, a rectangle being a four-sided shape, the longer side being the length, then the shorter side being the width. So the area of a rectangle is just simply given by length times width. And then now moving on to the trapezium. Trapezium as well is a four-sided shape with two sides that are parallel to each other, being A and B. So for the area of a trapezium, we say half multiplied by A plus B, then multiplied by the height. So in actual fact, you're saying half multiplied by the sum of the two parallel sides, being A plus B, times the height being the difference between these two sides. And then now moving on to the kite. The kite, this is simply a four-sided shape as well, as you can see. So what we do is that the area of the kite is given by half the sum of the diagonals. So here we've got two diagonals. If we join here and there, this point, the max top point and the bottom point, this will give us a diagonal B. And then if we join this point and that point, that will give us a diagonal A. So we're saying the area of the kite would then be given by half the sum of these two diagonals, A times B. Now moving on to the triangle. Area of a triangle, we know that is simply given by half base times height. So the base, there we have the base, and then the height, this is a line that is perpendicular to the base. In other words, this is a line that cuts the base at a 90-degree angle. So here we've got three lines that are cutting this base. We've got this line A, and then we've got this H, and then as well we've got that line. But we need a line that cuts at a 90-degree angle. That would be our height. So the area of a triangle will simply be given by half base times height. And then as well, there are situations whereby we are required to find the area of a triangle. Now let's say we are given this triangle, a triangle of the sort, right, whereby we simply have the base, side A, and then we've got an angle theta. So now, as you can see, we don't have the height. So what we need to do from this is that we have to express this height in terms of A. And from the knowledge of our trigonometry, we know that this being the longest side, which is the hypotenuse side, and this being the opposite side to the hypotenuse side is the opposite side, we can use the sine ratio, whereby we're saying sine theta, this being theta, whereby we're saying sine theta is given by the opposite side h over the hypotenuse side a, such that h in terms of a would be a sine theta. So now, if we are to substitute, in place of h, we now have to put a sine theta. The formula of finding the area of a triangle, if it's not a right angled triangle, it will be now half AB sine theta. So we use this formula in situations where we are given two sides and an included angle, right? And as well, for a right angled triangle, we just say half base times height. Now moving on to the parallelogram. A parallelogram, this is a four-sided shape as well, with two sides being parallel and equal in size. So this side and this side, those are parallel and equal. And then as well, this side and this side, those are parallel and equal. So now for the area of a parallelogram, we simply say the base times the height. The base, we have it, and then the height being the line that will cut the base at a 90-degree angle, right? And then in situations whereby, say, if we were to take example number 8, as you can see, we don't have the height. So the same way we deal with the triangle, we simply express this height in terms of A. So expressing height in terms of A, this is exactly the same as this. So this being the hypotenuse, then that being the opposite, we're saying that h would be a sine theta. So h being a sine theta there, the area of a parallelogram will be now AB sine theta. So this is how we calculate the area of a parallelogram. Now I would like to move on to look at these 8 questions. Now this is just a variety of rectangles, trapezium, kites, and parallelogram. So starting off with number 1, calculating the area of this rectangle, we simply said the area of a rectangle is given by length times width. Our length being 5.1, then times the width being 2. So there we simply get area is 10.2 square meters. That's the area of that rectangle. And then for number 2, that is a trapezium, right? As you can see, these two sides, they are parallel to each other. And then we said the area of a trapezium is given by half AB. Is given by half A plus B times the height, right? A plus B being the sum of the parallel sides. So we're saying half sum of 7 plus 4 to get 11 times the height. Height, we say this is the difference between the two parallel sides. So there, as we can see, it's 4. So 44 times 2, 44 divided by 2, that will give us 22. So the area here would be 22 square centimeters. So that's the area of that trapezium. And then I'm moving on to number 3 as well. This is the same example, right? This is also a trapezium. We're simply saying half the sum of the parallel sides, 8.2 plus 12.4, then times the height being the difference between the 2 points, which is 10. So if we are to calculate that, we are saying 8.2 plus 12.4, then times 10 divided by 2. So we get an answer of 103. So 103 square meters. This will be the area of that trapezium. Now for number 4, that is a kite, right? So now for this kite, we simply say the area is given by half the product of the diagonals. So we've got this diagonal, which is said to be 6 centimeters, and then we've got that diagonal, which is said to be 3 centimeters. So we're simply saying half of 6 times 3, which is 18 divided by 2, to give us 9 square centimeters. So that would be the area of that kite. Now moving on to number 5, we need to calculate the area of this triangle. But what we know about this triangle is that we know the base already, and as well we know the height. So we can simply say half base times height, which would be half of 14 times 9. So that would be 7 times 9 to give us 63 square meters. So that's the area of that triangle. And then now moving on to number 6, we need to calculate the area of this trapezium, for the parallelogram. And then we say for the parallelogram is simply given by base times height. So the base, we know it is 10.1, and then the height, we know it to be 7. So if we say 10.9 times 7 being the area, we simply get 70.7. So 70.7 square centimeters. So here we're saying 10.1 times 7. That should give us the area of that parallelogram. And then now moving on to number 7. Now we need to calculate the area of that triangle. But as you can see, this is not a right angle triangle. So we can't use half based on that. In actual fact, we need to use half AB sine theta. So now we need this angle being 70 and that being 70. This implies that this triangle is an isosceles triangle, which means that this is will be 5 meters. So now, if this is 5 meters, and this 5, and then that's 70, we need 2 sides and the included angle. So it means we have to calculate this angle by simply saying 70 plus 70 from 180, we get 40 degrees. Such that you are saying area would be now half, A being 5, B being 5, sine of theta being 40 degrees. So you're saying 25 sine 40 divided by 2. Right. 25 sine 40 divided by 2, we get 8.03. So the area for that triangle would be 8.03 square meters. Like that. Right. And then for number 8, just allow me to erase this part. Right. So I'm going to do the number 8 here. For number 8, we've got a parallelogram. But now for this parallelogram, we don't have the height. Right. Instead, we've got the side 10 centimeters and the side 7 centimeters, and the angle 70 degrees. So we said we use AV sine theta. So in place of the H, we're now replacing by A sine theta, A being 7 centimeters, theta being 70 degrees. So the area for number 8, area is now given by AB 7 times 10, sine of theta being 70 degrees. So I'm saying 70 sine of 70, right? 70 sine of 70 degrees. Let me change this. So we're saying 70 sine of 70 degrees. That will give us 65.8. So this will give us 65.8 square centimeters. So now that is the area that we get. And then now let me just confirm for number 7. Number 7, we said 25 sine of 40, then divided by 2. Yes, that one is correct. Okay, so this was looking at how we calculate the area of the shapes that we've just looked at. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.